Huh. I was talking, but I was muted. My apologies. So let's do this repeated. Head over to for all of you are here. Head over to tryhackme.com and try to find this reverse elf box, reversing elf. If you don't know what I'm talking about, let me know. If you know what tryhackme is, let me know, and we can do a quick walkthrough to get you spun up real quick. Awesome, awesome. I was talking and I was muted. Hey. Should be a pop-up somewhere that says you're muted. Awesome sauce. Let's see. Cool beans. So today's lab is going to be on reversing binaries or reversing executable files, whether that's in the Linux side or the Windows side. Pretty much what that is you're given a piece of software that's already compiled, it's already been run and it's distributed or whatever, or a piece of malware, and you don't know what it is. You're trying to find ways to get some type of information off this piece of software, binary or whatever. So there are a plethora of tools out there to do this, but this specific skill is called malware analysis, and it goes a lot deeper than the surface level that we're going to touch today. So if you are interested in that, I do have a few good topics, good study and tutorial points on that. But feel free to reach out on the Slack channel. Jedi is my Slack handle. Cool. So I hope we are all here on this reversing elf. Cool beans. As I said in the chat, it's easier to do these challenges on a Linux box, simply because most of the tools that we are going to be using are already pre-installed, whether that's Kali, Ubuntu, Fedora, any of those boxes out there, any of those Linux distros will be of great help to you in the future. Gianni, I think I'm saying that right. Gianni, you need some help. If you want to come off mute and let me know where you're stuck at. Yep.
Hi there. So I'm sorry, I just got out of work. I just need help finding the room. I just logged into my account and try hack me.
Alrighty.
Oh wait, I think I just type in the URL. My bad. I just realized that.
Yeah, wow. That's one way. But in the future, yeah, that's fine. In the future, whenever you log into it, you see at the very top these four little icons here. If you were just to type, you click on the learn.
Right. Oh, I see now. Okay. Learn.
Yep, and then go to all tabs.
Yep.
You search in the title of the title of whatever box that we're looking for.
Reverse. The name of the one that we're looking for is reverse files. You said, right?
Reversing F. Oh. Oh no, awesome. Oh well, let's go back there. Try this one more time.
Reversing elf room for beginners, reverse engineering CTF players.
Yep, that is it.
Awesome. Thank you.
Cool beans. And I believe I am still sharing my screen. Cool. Cool. So everyone should be here. We see this task 1, 2, 3, and whatever, all these numbers. We're going to try to hit as many as we can within this hour or so. So pretty much what you do with this one again is reversing the binaries, reversing ELFs. ELFs is pretty much the nomenclature for the Linux side, and binaries are PE header files are on the Windows side. Again, that's a whole new different deep dive topic into malware analysis that I am just now touching the surface for. But for task one, we normally would just download this file. You don't necessarily need to start your attack box on this one unless you are starting your attack box and you're trying to log in to try hack me through the attack box. You're trying to do some type of try hack me inception. Like I said before, all you need is just a good old simple Linux box or a Kali instance. But yeah, so what we do, we just click this little download button, and it's going to bring up a file. It's going to bring up something that looks like this. It might be a little different on your end, but all you do necessarily is just click the save file. And I'm gonna try not to show the answer in the future, but as you see, this is the answer. But we're gonna see how to get the answer in a second. But anyway, once the file downloads, right, it's either going to be in your downloads folder or your tip folder. But the quickest way is to go inside your browser, click this little download button, and then it'll bring you right into the containing folder. And then at that point, we're going to open up a terminal on our end, on your end, wherever that's going to be downloaded at, your tip folder, your directory folder, your download folder, any of those. Excuse me. All right, and so once we have that binary downloaded, right? Sorry about that. Yeah. So once we have that binary downloaded, the first thing we're gonna do is let's see where it's at. The first thing we see crack me one, and it's a read write file. These are the global permissions for user, world, and owner. I forgot, just to make sure. And it's pretty much to say is who can access this file right now, right? But if we look at the clue, if we go back to our task one, and we look at this clue that says, let's start with the basic warm-up. Can you run the binary? So what that's telling us is pretty much, let's see if we can run this binary. See if we can execute this file. Normally would not do this. Normally would not do this with just some random piece of software that's off the internet, because you don't know what that piece of software does, right? And so a few commands that you can look at first is, let's say, the file command, file on the crack me one. And if you don't know what file is, there is this neat little dictionary type deal in all Linux distros. It's called man, and you type in file, and it's going to give you pretty much what the command is, what it does, what flags you can pass to it. Flags meaning things are like this, like the tag C, tag D, tag EF, things of that nature. I'm not sure what that was. But yeah, if you don't know what something does it, if you don't know what something is that you're trying to run in your Linux, pretty much there is going to be some sort of instance of the manual. That's what man stands for, manual. And you just run man on that command. To get out of this, you just hit the Q button. So again, so we run file just to see what type of file this is. And it's going to tell you, hey, this is going to be an F. It's going to be a 64-bit executable. And it is a Linux distro, and we have some other stuff that's on here. The most important part of this one is that this code right here, or one of the most important pieces, is this little piece right here, not stripped. And what that means, what not stripped means, is they have debuggable strings in there or functions in there, and that we can see within this binary. Do I have one that's not? Let's see if I have one that is not stripped. That is stripped. No, I don't. All of these are stripped. All right. But anyway, again, so what that means is that we can see some type of comments or see some type of information within this crack me binary. So how do we get some of this information that I'm talking about, right? There's this nifty little command called strings. This nifty little command called strings inside of your Linux box. And I am back. So yeah, so we run strings on the crack me, not two, but one file, right? And these are all the, when I said not strip, these are all the things that are going to be readable, human readable within that binary. And these are all the strings that are just randomly placed in there. Some of them are based off the operating system, little flags that's inside the code that when compiled, that's beyond the scope of this. But these are all strings that can be read inside that binary. So how do we run this thing? How do we run this piece of code right here, right? Normally on the Windows, you're used to just double clicking on something or double clicking on a Linux box and then it pops up, right? Within the Linux side, there is this thing called shell, or it's run as root sudo. What is it called? I forgot what I'm called. But the way you can run this file is we crack me. Can't fucking type, right? There we go. Crack me. And crack me one. Permission to not. Why is permission to not? Let's look at this file again. Probably because we don't have an executable bit. And that's that executable bit is going to tell the operating system, hey, this is an executable file, and that you can invoke this file, right? So how do we add this executable bit to this crack me file? Let's see. There is this little command called change mod or chmod. I can type one more time. Again, if you don't know what this is, let's find out. Type man chmod. It's going to give you change the file mode to bits. Let's see how we can add an executable file, right? Add a executable bit to a, what is that noise? Is someone raising hands? Nope, I don't think so. Keep hearing a beeping sound. Anyway, so yeah, we're going to use this chmod command, right? So let's use it. Chmod plus our x stands for adding the executable bit. You can do this within numbers, something like that, but that gets a little bit say complicated because you must know what those bits represent in each of those fields. But it's going to be for easier. It's going to be for ease of use. It's going to be chmod plus x in the crack me one binary, right? And then if we look at the file again, we see that it has changed colors on us, and we have read write. We have executable all around every user, global, and but for its owner. And if you remember before, we didn't have those executable bits. So how do we get there? We added the executable with chmod or change mod, or however you want to pronounce it, chmod. We just added an executable bit. So now that we have the executable bit, what does that mean? That means that we are now able to run our file in crack me. And that's pretty much the answer to the file. Let's see if we can run it. And if you put that in, you should get a success. Should be able to run that. Was that good enough, everybody? We good? Thumbs up. Everybody so far following? Awesome. Cool beans. All right, let's move on to task two. And it's pretty much going to be the same steps throughout majority of these, where we are going to download this binary and analyze it using different tools and different methods, right? So if we were to bring this down, I've already done it. Download the file, right? Download the file down, bring it over to wherever directly you want to, and let's run it. Again, we don't want to run some random software off the internet without actually knowing what it's going to do. 9 times out of 10, when you're doing malware analysis, you're going to have a dedicated box for malware analysis. Because you don't want to continue the infection of or spreading that malware out in the world or into your corporate, your network. So again, we're going to hit this file button. This file command on crackme2. We see that it's not stripped. Again, that's the most important portion of this, that it's not stripped. That is a 32-bit Intel. And we got some pretty good information here. So let's see if we can run some strings on this, see if we can get some strings off of this, actually. We could either use the hex dump. Hex dump is another command. Can't tell you what it is. If you want to know, use the men and hex dump it. But this is going to give you some ASCII characters in crackme2. And this is the printout of hex dump. This is a little archaic. But if you can read this, it's pretty awesome. These first bits are called magic bits inside of a file. And these magic bytes or bits tell the operating system what type of file this is, right? And that's where we get this portion from, the F portion. And I believe on Windows, it's PE header files. Yep, the PE files.
Sorry, can I ask, why did you run hexdump? Did you see something?
We're just doing the say the high level basic analysis of a binary. So if you normally, like when you're trying to read a book or whatever, say for instance, you're reading a book, you're gonna read the back cover of the string. The back cover of the book, the front cover, just reading the strings on that book to see what the book is about, instead of actually opening the book and reading every page. And running a hex dump is just running a hex dump in the ASCII format. It's just going to give us like a high summary of what's in this binary that we can see, like the type of strings that we can see.
Got it. Thank you.
Another readable format is this. Another easier way to read this is using that good old strings command, right? Strings on crackme2. And this is pretty much the same thing that's already here in this hex dump, but it's going to give us a tad bit more easier on the eyes. And just off the bat, we can see something that says usage, string formatter with a password. Awesome. And you see something that says secret password. All right. So what does task 2 ask us to do? It says find the secret password and use it to obtain the flag. All right, cool beans. We've already got it using the string command. Using the strings command, we can see that there is this super secret password, right? And this can be normal within software when the developers create these hard-coded strings within this binary. It sometimes is just as easy as just running strings on it and getting the password out. But how do we use this? How do we use this password? How do we use this super secret password? We have a usage command or a usage text right here. We don't know how to use it, right? So it goes back to the crackme one. We have if you see they're both different colors, right? So how do we add this executable bit? Does anybody know how to add this executable bit?
Yeah, chmod plus X.
Yep, is correct. So let's do it again. So chmod plus X, crackme on it, crackme2, we're awesome at it. And we are about to run it, crackme2, and it says exactly what we saw in the string output is, hey, usage string password. So with that super secret password copied out from strings, we are passing it to the crackme2 file, and we should be able to get our flag and our answer to our task 2. So with that being said, I am going to I am going to give about 5 minutes on task 3 to knock out task 3. Again, go through the basics, what we just learned here using the file command, string command, and adding that executable bit. And if you run into any problems, shoot me a text or just come off and let me know. Come on, unmute it. There you go, and let me know. But yeah, 5 minutes to try to crack this task 3 out. 18:35. Cool beans. Put my music back on. Yeah, feel free to come off mute anytime. I'm not the only one that has to be talking. We can all talk. We're all learning from this. We're all learning in this mode of learning from each other. And it's a lot funner that way. Awesome sauce, awesome sauce. Oh my Jesus. It's a lot of pressure in this thing. It's only in the tech team. That's cool. Oh, let's see if it's here. Interesting. Let's see what it is. Do it later. Later. Jesus. Tight. There you go. Cool. Alrighty. We got like another 30 seconds. Was anyone able to figure this one out? If so, do you want to walk me through this? Oh, all right, cool. Let's do this then. Anyway, so we will now download this little binary right here, and we are on the Track Me site, and we are on the Crack Me Top 3 file. Let's see what this says. So here on the file, crack 3, crack 3, crack 3. Oh, 23. Oh, strip. Oh, we did have a strip one in there. Interesting. Okay, cool. So let's see what that is. Again, remember what I said earlier about being stripped and not stripped is we have some debug output in there as well. Let's see what we get out of this. Interesting. Okay. I see some interesting strings. Connie from my aunt Mildred. Got this one. Correct password. This stands out to me because this looks like a base 64 string. Let's see what this is. Actually, let's add the bit on there. Haven't done this one in a long time. Cracking 2, cracking 3. There we go. All right, and let's see if we can just run this. It's probably quicker to type it out. This is cracking 3 password, okay? Was that well, that was the hash password. So if it's the hash password, let's see. Actually, let's do it this way. We can, let me show you a tool before you go. There is this thing called CyberChef, I believe it was called. CyberChef. And normally what I would do is take this little long string right here and try to decode this string. It looks like it's going to be base 64, but we can, let's see what it's called, hash finder, hash ID. This little thing called hash ID to actually tell me what type of hash this is. So paste this out. What is it? Hash finder. I'll come back to that one around that time. But yeah, so CyberChef is pretty easy to go. It's user friendly.
So Jetta, the one I use is called hash identifier.
Hash identifier. Okay, cool beans. So yeah, hash identifier is a good one. But to get back to the CyberChef, to make this stuff a little bit easier, right? Stuff automatically for you. So we just drag it to this little second window, this middle window right here, and we bring over our hash. Paste it. And it decoded the hash that we brought over to for your second lesson on base 401. I wonder if that's about. Let's find out. That's interesting. Figure out how to do this one. Cool beans. Let's find out though. Cool. I guess that was it. That is your answer. The decoded base 64 flag. And awesome. And we can run through crack 4 because I have not done this one yet. Analyze the binaries. Okay, cool. It's already downloaded. Yeah, so cracking 4, it's going to be the same way. As you see, I've not done this one yet, so we'll probably go through this one together just to see what it's like. I don't need this one. Let me figure that out. Cool beans. Cool. So let's see what this file tells me about itself. Cracking 4. It's not stripped. So that must mean I can run some good old strings on it. Cracking 4. Bounces. What does our code say? Analyze to find the password for the binary. That's all it tells us to do. Okay, that's fine. What I'm looking for right now is, again, any strings that stand out. The usage password is not okay. The string is hidden. This is a cool little comment. This string is hidden using string compare. What this is another C function. It's a programming language. C, C++, Python, Java are all programming languages. Majority of Linux files and Linux commands are written in C. And what this is telling us is the string is hidden in a function that's used by C in the string compare function. Okay. These are library functions, so that tells me that I'm going to have to run probably Radari or some GDB. And what GDB is another Linux debugger. And what a debugger is pretty much just going to try to debug your binary. Where is this? Okay. So GDB. Actually, let's add that flag first to make it executable, just to make sure. Run it. Okay, before. Interesting. Okay. Fucking type. Cool beans. The string is hidden and use string compare. Same thing, same learn notes I got it here before. Cool. So GDB. That is GDB. So I don't have GDB installed here. No, I don't have GDB. App install. GDB. New debugger. Yeah, it should be in there. It's Cali. GDB cracking 4. What? All right. There is something going on with this. So there it is. Let's see if we have it in our there's information gathering debugger. So let's do one for Linux. Besides IDA. Where are you at? Where are you at? Password reverse engineering. Nazim Dari. Lane. Exploitation. Where is that one at? Oh, 1 second. This should be in there. Kali install GDB. So capture. What's happening? I have enough time. Oh, that's the wrong one. Whatever. Ain't that about something? Let's go ahead and use Radari too. Oh my Jesus. Okay. So it looks like we are having some technical difficulties over here. Let's try this one more time. What's GDB plus? Let's see what that is. And GDB plus. 2 for working with the plus. Oh, that's not it. It's definitely not it. We're going to Radari 2. Yep, Radari 2 is there. So let's try crack me. Radari 2 is there. 4.
It's installing GDB for me.
Say it one more time. Oh, no,
I was able to install GDB with that command.
really? Interesting. Let's try
Are
this
you
one more
able to?
time.
Are you able to ping the internet or something?
Yeah. It says mission not. So let's see. Let me see if I can just use Redari. The Redari is another colorful version of GDB. Let's see what that is. Lots of flags. Run. And so functions. What is it? Info registry. Display. And we're going to analyze commands. Analyze A. Let's analyze some functions. Oh, that takes so long. One second, guys. Normally I'm prepared. Redari, there we go. Redari cheat sheet. Google. Redari. Cheat sheet. Redari cheat sheet. This is freaking capture, man. Oh my Jesus. Let's do this. Google. Cheat sheet. Here you go. Outside third cheat sheet. You can find it in master repository. And let's see, return to conversion properties. Commands. Let's examine. Well, if you got GDB installed, pretty much what you're trying to do right now from just reading the commands and reading the hints is you're trying to look at the functions and the registers, right? So you're trying to look at the functions and the registers. And I believe there is a command in GDB that says displays info or displays functions or display main or something like that. That gives you the function names of that. I think it's called info functions. It gives you the function names of the all the methods that are in that binary. And from the hints, you're probably going to look for the method that has the string compare str cmp, I believe it was. So I don't want to waste your time. I'm trying to figure out this issue on my end. So I'll tell you what to do. But yeah, so you're going to look at the string compare. And pretty much you're going to try to either see what register that is gets called from. I mean, what method that is called from. And try to find that address space. And once you find that address space from running info functions, you should be able to drop in a wherever that address space leads you to into that memory, and then you should be able to read the values of that register and hex dump it out into a readable ASCII format. If I can get this Redari to work, oh, man. Redari. Let's see that one more time. Redari cheat sheet. Where you go? Copies. Let's go to, if I have info, let's go back to here. And then I'm going to display change the box speed. See. Oh, this looks helpful. Oh, who's the information? IR. Oh, let's see what that is. Ha. There we go. We don't have anything in there yet, so let's go to functions. Information on that. Information on functions. IF. Well, cool. I am running into some no difficulties in this one, technical difficulties per se. If you're able to get GDB running, there's a lot of GDB tutorials out there. Pretty much, again, what you're looking for is the string compare function, and you're trying to see which A or something like that, or AX or AP, to see which two are passing to that string compare function, and that's going to be your answer. But I'm not going to sit here and try to debug this Radari. I'm trying to fix this box. With that being said, I'm going to call it a night from right here, from this point on. I'm going to keep the camera on, try to figure this out, but this will conclude Friday Night Labs, and feel free to stick around if you want to watch this out, watch me debug this problem or not. But if not, then appreciate you joining us. Thank you all for coming out. I hope you learned something here, and good night.
Thank you and good night.
I'm going to try to figure this out. Let me see. Let's go back to A. All flags in this. That's classes. Oh, there's two buttons. Let's see, is that before? How do I get my display to work? And how do I get my display? Actually, you know what? Let me see something. With a quick exit, there we go. Go back to install that. I have permissions and now sudo. Let's see if I can. Not this one. Yeah. Forget it. I forgot my password. There you go. Yep. Let's see if I can get this right here.
What was the issue?
This one, well, but the earliest it was it was locked on the package installers. I'm not sure.
Okay.
And, okay, we got 25 seconds left. And I can do this. It's interesting. Let's go. 95, 100, and we are loaded. get it, lady. Let's get it. I don't know for something. Let's go back over here. Let's go over here. No, it's not there. Ha, cool beans. Easy. Awesome. Cool beans. Easy. Cracking for. Oh. Interesting. Cool beans. All right. Cool. Awesome. In there. Let's go with insert funks. Function. Aha. There we go. Good old GDB came to the rescue. It says binary. I'm trying to run. All right, let's see what that is again. Just shoot compare. Okay, so I'm going to do this. See, that's going to break it. For all the functions right here. There we go. This one. This is print. This one compare. This is main. So you can break on this. Let's break on this. Let's see what rich we get here. Okay. I don't know what that does. Next. Refresh. All right. Break it at this point. Same function, same one, same string as before. Let's go ahead and break that out. Breakpoint set. All right, cool. All right, cool. Let's do. And it asked for a password, didn't it? So, it's not a password. So let's do something. Breakpoint hit, right? So, info registry, ha, cool beans. This is 36B. This is our string compare. This is our flag. This is our pointer. Registry pointer. So normally the way it works is going to be string compare passing to this AJAX. But we're probably going to get this one right here then. Right? Is that what I'm I think we can look at that. Let's see what this is. Let's see if it examines them. This is the first one. This is the method. And let's see what that was. Okay. So let's examine some bytes. Let's examine the string for, let's say, 10 bytes. I think it's this one. Yeah. Oh, whatever. Let's go here. This address space. Copy that address space out. And delete that address space out of the way. That address. And it's not this one. Oh. Wait. And then string car. There we go. And then we can go, let's see what the other two strings are. Aha. So there's this one. Copy this. What he said, where's my password? comparing to this. Oh yeah. Awesome.
So what was the meaning of the X by 10s?
Say again.
What does the X by S do?
It's going to tell you to examine a range of addresses or address space, and you want to do it in the string. You want your output to be a string. I believe there is another one, hex, and I believe bytes or binary.
Okay.
But string is just what we see here, stuff that we see here.
Okay.
But cool. I'm glad we saw that together because that was going to make me mad. Anyway, so yeah, we ran into some problems. So now we got it. We figure out the answer. What time is it? Oh, I figured out right at the time too. Right at 7, or right on top of the hour. But yeah, that is going to be it from my end. I'm glad you guys stuck around. Hope you guys learned something new on that one. We had some little technical difficulties, figured it out. You're going to run into those. You're going to run into those plenty of times in life. You just have to keep going and try to, stay calm and work through the problem, find a solution. But yep, glad you guys stuck with me. We got the answer, and that's going to be it. That's going to be it for my end. I appreciate you guys sticking through.
So if you could share some of those resources in the Slack channel.
You mean the Radari and the GDB and some of the commands?
No. Before that, you said for reversing, there are some resources to learn slowly as a beginner.
Oh, okay, gotcha. Right. Okay, yeah, I surely can. There's Try Hack Me has a pretty good malware analysis as well. Let's see if we can find that one. Let's see if we can find that one. There you go. I don't know why I did that twice. I'm sure. Forensics. There you go. So these two will bring up pretty much everything that we need to know. This malware introductory course right here. It's pretty sweet. It's pretty good. It's pretty informative to teach you some good malware analysis techniques.
Okay.
But yeah, I would definitely post stuff that I normally use. Some of the stuff that I go through inside the Slack channel as well.
Sure. Thank you so much.
Roger. No problem. Any other questions? Cool beans. My more secure password. That's interesting. Awesome. Cool beans. Well, again, guys, that concludes Friday Night Labs. Hope you learned something new. Have fun. Happy hacking. Talk to you guys later. See you next week.